Okay, 9.4, real numbers, okay? An irrational number cannot be written as a quotient of two numbers. Meaning, if I get a decimal that keeps repeating, 0.0101010101, and it keeps going on and on and on and on and on and whatever, it's irrational, okay? Something that repeats consistently, however, is not irrational. Like if you have 1/3, right, when you put it in your calculator, you get 0.33333333.
Yes,
That's not irrational, that's still a number, because it's the same thing always, okay? So irrational numbers, a lot of times we've gotta divide them out and see what the decimal looks like, okay, to decide if they're irrational or not. A real number consists of all rational and irrational numbers. So then they give us this diagram and they say, here's real numbers, okay? And then they split this in half. One side is irrational numbers, one side is rational numbers. Under rational numbers, we have subcategories, integers and whole numbers. So whole numbers is all three things. And it's a whole number, it's an integer, it's a rational number, it's a real number. Okay? Integers are just integers, rational numbers, and real numbers. Rational numbers, real numbers, okay? Irrational, real. So we're gonna start to classify some numbers. How do you think, what do you think I should do to try to classify these numbers?
Simplify?
Break it down.
Wait.
What do you mean break it down, Bree?
Like divided by?
Like divided by, yeah, like divided by. So if you have 5/8, I need everyone to have a calculator out and I need you to tell me what 5/8 is. And then we gotta decide, is it rational or irrational? Okay? Tell me what 5/8 does and we'll decide what it is.
0.625.
What?
0.625.
0.625 is what it comes out to be, correct?
Yeah.
Okay, so this equals 0.625. So we wanna decide if this is rational or irrational. What do you think it is?
I think it's
Irrational?
rational.
Okay, let's talk about that. Why, Sonia, would you think it's irrational?
Well, because it doesn't repeat like a number over and over
Okay,
again.
does it have to repeat to be rational?
No.
Not necessarily. Okay, why do you think it's rational, Matthew?
Because it doesn't continue on.
Good. Okay, look, this stops, right? It gives us 3 numbers, it's done. It makes it rational. It has a stopping point,
So if it,
okay?
so if it doesn't stop, then it's not rational?
Sort of. We're gonna get there.
Oh, so it has the like
A little bit, that's part of it,
Well,
okay?
if it
Yes,
stops-
unless it has like a constant repeat, let's
So
talk.
rational is when it doesn't go up.
Not necessarily.
Okay.
We're getting there. Let's do the next two and then we'll make connections, okay? What does 5/6 come out to be, guys?
0.83.
Oh, that's.
Okay, so what's going on with that 3?
irrational. It just continues.
It keeps continuing, but did the number change?
No.
No, it stays at 3. You guys have seen that little mark before,
Yeah.
tell me it
Yes.
repeats,
Yeah.
okay? So do you think this is rational or irrational?
I think it's irrational.
You think it's still rational, Gabby?
Yeah.
Why?
Because it doesn't repeat over and over again, like two numbers don't repeat over and over.
Okay, or it's not switching back between a bunch of repeating numbers,
Yeah.
okay? So this is also rational.
Oh, it is?
Mm-hmm. Okay, and the reason this one is rational is because when it continues on with the same number. It's consistent.
Okay, so if it's consistent with the same number, it's still rational.
Correct. Yes.
Okay.
Okay, so the first one, listen, this terminated, that's what we call it, terminated. This one repeats, but it's repeating the same thing, okay? Or if it repeats the same pattern, it's still rational. So 1 0 1 0 1 0 1, it's the same repeat. But if it goes 1, 0, 1, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 0, 1, that's not the same pattern,
Okay.
okay? So then let's look at the next one. Radical 19, plug that in and tell me what we get.
4.35888944.
Okay, that's not, like, that's irrational.
Why is that irrational?
It doesn't have any clear pattern.
It doesn't have any clear pattern. It doesn't repeat the same number over and over, right? Okay? This
Can you
is
write that?
irrational. What'd you say?
So do we have to write that whole thing out?
No, you don't have to read the whole thing now. It is a non-terminating, non-repeating number. Non-terminating, non-repeating makes it irrational. Non-terminating, non-repeating. Okay? First one, terminated. Second one, repeated. This did neither repeat nor terminate. Okay? Irrational.
But then they terminate after that.
No, your calculator doesn't go as far as it needs to go. Okay? It will go on, my calculator goes a little further than yours, but it will go on forever. What?
Dang.
What does terminate mean?
Terminate means like there's a stopping spot. Like when we put this in, it was just 0.625. There's nothing after it, right, Carter? Okay, just stop. Okay, it has a cutoff. Okay, let's talk about some number lines. You're gonna do number lines tonight, sorry.
No.
Okay,
Not
but
enough.
luckily, with our number lines, we're gonna do one of two things. We're either gonna order stuff from least to greatest, or we're gonna say this is greater than, this is less than, or this is equal to something. So you're gonna see problems like this. It says copy and complete. So on your homework, you'll copy it and you'll complete it.
Lovely.
It says radical 2 is what compared to 9/5. That's what this means. Radical 2 is greater than
Oh.
9/5, less than 9/5, or is it equal to 9/5?
So you have to graph it on the number line.
So we need to graph it on a number line. Well, what is radical 2?
Wait, it's
1.414213
Okay,
1.4.
so it's 1.4-ish, right?
Yeah.
So I would put it someplace like right here, but when you graph this, I do not want the decimal, I want what they originally gave it to you in. So you're gonna write radical
Oh,
2
okay.
above it, okay? You
nine.
do not write the decimal, you always write whatever they give you. Now listen, we're gonna have to turn all of them into decimals because we need to compare, right? But when I write them on the number line, I need them in what form they were originally in. What is 9/5?
1.8.
1.8?
Yeah.
Okay,
It's
1.0. I'm stupid.
what?
This is 2. So this is 1.25. What was radical? That's 1.
1.8.
So it's gonna be like this. This is 9/5. This is. It's a half, so that's gonna be like right here. This is radical 2. So is radical 2 greater than, less than, or equal to 9/5?
Less than.
So then my answer is radical 2 is less than
Oh,
9/5.
that's pretty easy.
Okay? Yeah, it's not hard. You guys have done this before.
Yeah, I think we have.
Okay.
Yeah, but both number lines, too much work.
Yeah, it's just with whole numbers or with just.
Oh.
Okay, use a number line to order these numbers. 4/3, -2.8, radical 3, and negative radical 5. I automatically know which two numbers are going to be the least. Which are those?
The negatives.
The negatives, okay? So I'm gonna, you can do this however you want. We can just go in order, or we can start with negatives and work our way up. I don't care. I say you go in order just to make it easier,
Mhm.
so you don't forget something. What is 4/3?
It's positive.
It is positive.
It is 75%, which is 0.75.
No,
That was close.
it's 1.3 repeated, so it's 1 and
Three, 1 and a third.
1 1/3. So let's say that it's about here, yes? Once again, you need to write this
4/3.
back as 4/3. Okay, and it says from least to greatest, so when we order them, of course, it will be least to greatest if we number our
Do
number line
correctly.
correctly, yeah. -2.8, that should be an easy one, where do I
Yeah.
put that?
A little bit below the 2.
A little bit below this 2?
Yeah.
A little bit over here, right?
Mm-hmm.
Okay, radical 3,
1.7.
1.7, was that more than 4/3?
No.
Yeah,
Yes.
yes,
Cause 4/3 was 1.3 repeated, right?
yeah.
So 1.7. Okay, so radical 3. And then negative radical 5,
Wait, so that's,
Negative 2.2.
negative 2.2. So it's like right about here, which is actually greater than negative 2.8, yes?
yeah, well, yeah.
Okay, and that's what you're gonna do.
So that 5 is negative, even though the negative is outside the radical.
So just plug into your calculator radical 5, and you'll get 2.2. But know that because the negative's on the outside, it's like taking it and multiplying by negative 1, right?
Oh, so
Don't
that's,
you say like
yeah,
Jesus is there or something?
Jesus,
Yeah.
everywhere.
So there's a negative being multiplied to whatever you get out of that radical, okay?
Okay.
Okay, now, word problem time and then we're done.
No!
So,
So we just leave it as the graph?
yeah, you just leave it like that, number line, that's all it wants.
Funny.
Yeah, this is all we're doing. Now, I'm gonna, use that graph board over there for a second to do this, because it's easier when you have graph to do this, okay?
You want us to use graph papers maybe?
I don't know, I think you only have like one problem like this, so don't. Says your class is visiting historical landmarks in Chicago, outside the Washington block. You break up into 2 groups. Group A walks about 800 miles east. It was supposed to say, it's supposed to say 800 meters. I wrote down the wrong measurement. So,
Speeders.
800, because miles would be insane, right?
Yeah.
800 meters east, okay? And group B walks about 600
miles.
meters east,
Yeah,
okay?
I'm sure they did.
I like to walk
Or
miles.
meters south and 200 meters east, okay?
I like to walk 600 meters. Miles.
To the nearest 10 meters, how much further is group A from the Washington block than group B? Okay, so here's what you need to do. Let me tell you how we do this. We need to draw this out, because here's what's gonna happen. You're gonna get a triangle, and then you know how to solve side lengths for triangle. You use what?
The
The Pythagorean theorem. The Pythagorean theorem. Okay, so let's pretend that 0, 0 right here is where we started, okay?
Is that where we broke off?
That's where we broke off. Okay, we're just gonna use that. That's why I said it's easier to do on a graph, because I can just use that as my center point. Okay, the first group walks which direction?
East.
And how many meters?
800.
I'm just gonna use, one of these is gonna represent 100, okay?
Oh, okay.
So east would be that way, yes?
Yes.
So 5, 6, 7, 8. They walk this way, correct?
Yeah.
Okay, 800 meters east from their starting point, yes?
Yeah.
Okay. The other group,
That graph?
they walk 800 meters east.
So -6.
Oh, and they should walk, there should be more on here too. They also walk 200 meters south,
Do
okay?
what now?
200
meters down.
Who did?
Group A.
Oh, group A. Okay.
Yeah, they walk 200 meters south, which is down.
Yep.
So here's the other point, okay? So then look, you have this, yes?
C.
That's a triangle.
Yep, it's a triangle, so
It's
this
right
So
triangle.
we're gonna
So
have
this
some
is
triangles.
800, right? And this is 200. Okay.
That would be a lot easier with that.
Yeah, that's what I'm saying, right? Okay, so then, the next group walks what?
No, 600 meters south and 200 meters east.
600 south, 200 east.
-6.
Okay, so minus,
Oh, Lord have mercy.
that's where that chair went. Okay.
Ah.
600 south, right?
Yep, and 200 east.
And 200
Yeah.
east, is that what it says?
Yeah,
And 200 east.
another triangle. It's the same triangle.
No, it's not.
Wait.
It's different.
No, I mean.
So now we wanna
Oh,
know
no,
which
it's not,
one
sorry.
is further away, right?
Okay.
Or which group is, how much further is group A from the Washington block than group B, correct? Okay,
So we're looking for the difference?
so we're looking for those hypotenuses, because if I find those, I'll know which one's further away, because that hypotenuse is a direct route to the starting point, yes?
Mhm.
Okay, so if I do for group B, or for group A, how do I have to set that up?
Oh, it'll be A squared
A
plus B
squared
squared
plus
equals C
B
squared.
Okay, and what's my A and B?
200.
Your A.
200 is
Your A is
A.
200,
And
your
your
B
B
is
is 800.
so it's 200 squared plus 800 squared equals C squared.
Okay, so let's do that. 200 squared plus 800 squared equals C squared. What's 200 squared?
Okay. 4,000,000.
4,000.
40,000.
40,000.
Oh,
Okay, what's 800 squared?
64.
64.
64.
640,000. 640,000. You okay, Bree? Or Gabby? Oh, was
Bree.
Was it Bree? Okay, I was right the first time. Add those together, and I get
Get something.
680,000 equals c squared.
Radical time.
Radical term, take the square root of 6, 8, and then 4 zeros. And you should get, and it says round to the nearest 10 meters, okay? So I should get,
Oh, it's
825, because I get 824.6.
Yeah.
Okay, so round up, so 825 meters equals C, okay? Now, on the next one, what do I have to do?
You have to do the same thing.
And what are my numbers?
200 squared plus 600 squared equals c squared.
Okay, well, good news is this, we know
Pardon?
200 squared is 40,000. What's 600 squared?
360,000.
360,000, good. And then when I add those together, what do I get?
400,000.
400,000?
Yeah.
And what's the square root of 400,000?
632. I'm gonna say that.
632
And then it
meters.
says like 0.4.
Okay, perfect, so 632 meters. And it says, how much further is group A from the block than group B? So what do I have to do?
825 minus 632.
Good, 825 minus 632, what do you get? 193?
I don't know.
So they're 193 meters further away.
Group A is.
Yes.
Okay.
Okay, they traveled a little bit more of a distance. They must have Mrs. Granger leading them. And not Mr. Diatori, right? Mr. D likes to take his time and
Yeah,
explore
he
stuff.
takes his
Mrs.
time
Granger's
a
like,
lot,
you've
but-
seen it, let's go.
Are we done?
Yeah, she's gonna walk you to death in DC.
Okay. That's
Okay.
good to know.
Yes, we are done. That
Can I
is
take a
what we're
picture?
going over. Yes, you may take a picture.